Okay, page 4, last page of the study guide. Hooray! Um, if theta is in between 0 and 90 degrees, and sine of theta is root 5 over 3, then what is cosine of 2 theta? We have a bunch of double angles for cosine. Since we're given sine, let's use the one that just uses sine. We can know that cosine of 2 theta can be equal to, oh, gotta memorize these because I didn't bring my list home. Should be 1 minus 2 sine squared theta, I'm fairly sure. Yeah. So do that, and then we can just replace everything we know in here. And this is, you know, theta is in 0 and between 0 and 90, so we don't have to worry about negatives. They will pop up as we needed. Okay, so let's see here. We have, this is going to be equal to 1 minus 2 times sine squared, so that's going to be sine the square root of 5 over 3 squared, which is going to be equal to, now, this right here, squaring 3 is going to be 9, so I'm going to go ahead and make make my 1 a common denominator. Minus 2 times, well, square root of 5 times 2 is 5, and 3 squared is, sorry, square root of 5 squared is 5, 3 squared is 9, so we're going to get 9 over 9 minus 10 over 9, which is equal to negative 1/9. So negative 1 over 9. Done. Number 12, simplify. Simplify. So the first thing we should look at is that these two trig functions don't have the same angle. So there's not a lot we can work with unless we can make them have the same angle. So let's start with saying this is equal to 2 cosine theta, and we can change sine of 2 theta to be 2 sine squared theta. No, not 2 sine squared. It's 2 sine theta cosine theta. Yes, that is correct. And then we can simplify something. I have 1 cosine up here. I have 1 cosine down there. So that gives me, oh, and then this 2 will simplify with that. So that leaves just 1 on top and leaves a sine theta on bottom. And 1 over sine theta is equal to cosecant theta. And we're done. Okay. Number 13. If sine theta is equal to 3/5 and theta is in the second quadrant, so that tells us second quadrant is negative positive, find each of the following. Sine of 2 theta. So sine of 2 theta is equal to 2 cosine theta times sine theta. And we already know sine theta, so we can replace all of that with 3/5. And we don't know cosine theta. So we need to figure that out real fast. So let's go over here. If I know sine is equal to 3/5, well, we have a theorem that helps us figure out cosine. We know that cosine squared theta is equal to 1 minus sine squared theta. So this is defining cosine. So we can replace everything we know. I know sine is 3/5. And so we're going to have 25 over 25 minus 9 over 25. So we know this is 16 over 25. Cosine squared, 16 over 25. Root both sides. Cosine theta is positive or negative 4/5. And because we are in quadrant 2, we know that cosine is negative in quadrant 2. So we know cosine has to be negative 4/5. And then we just multiply across. Negative 4 times 3 is negative 12, times 2 is negative 24, 5 times 5 is 25. So negative 24 over 25. Next we have cosine of 2 theta. This one, we have 3 different formulas we can use. I'm going to use the one that uses sine because that is given to us. And it is 1 minus 2 sine squared theta. And I know sine squared, or so I know sine is 3/5 squared. And that's going to end up being 25. So we'll make this 25 over 25. So we get 25 over 25 minus 9 over 25, which is equal to, oh, I forgot a 2. There's got to be a 2 in there, so 25 over 25 minus 18 over 25, which is equal to 7/25. Bam. Okay, almost done. 2 more questions. Simplify this thing right here. So, again, we have a problem because these are not the same angles. They are different angles. So let's start with making them the same angle. Sine of 2 theta, that can be simplified to being 2 cosine theta sine theta over. Now, I saw a lot of people switch this over to 1 minus cosine squared theta, and that is totally fine because it's true. You are allowed to do that. But in this case, I don't think it's helpful. And usually it's because essentially the addition and subtraction. If you have a lot of multiplication and you're simplifying things, you don't want to introduce addition and subtraction because they are obnoxious operations that completely kill any kind of simplification. They just ruin it. So we want to keep as much multiplication as possible. So I say don't make that switch unless you're just out of ideas and you want to try something to see what happens. So for now, I'm going to leave this as sine squared and just make one change at a time. So let's see where I can go from here. Well, I have one sine theta on top. I have 2 sine thetas on bottom, so I can simplify that out a little bit, get rid of one on top and one on bottom, which will leave me with 2 cosine theta over sine theta. I'm going to show one extra basic step here. If you didn't write this step in, that's totally fine, but we can pluck this 2 out and just say this is cosine theta sine theta. And cosine over sine is cotangent, so that should leave us with 2 cotangent theta. I just heard a big crash on the other side of my house. It's either my dog or my daughter. But I got one question left, and then I can see if everyone's still alive. So, simplify 1 minus cosine squared x over sine squared x. So we're looking at here, and once again, addition and subtraction, obnoxious stuff when it comes to simplifying. So is there a way we can get rid of this whole thing right here? And there is. 1 minus cosine squared is equal to sine squared x. Bring this one over, sine squared x. And that's just sine squared x over sine squared x, the same thing over the same thing. They would cancel each other out, leaving just 1. And that is it, folks. That is the study guide. I hope this is helpful, and I will see y'all on Monday. Have a great rest of the weekend.